Hello, and welcome to the Math 0362 Test 1 review. Thank you for tuning in today. Hopefully this review will help you when you take your first exam. Question 1 would like us to factor out the greatest common factor. With the numbers, I see 15, 5, and 10. So the greatest common factor will have 5 in it. And then I also see U7, U6, and U5, the smaller being U5. So the greatest common factor is 5U to the 5th. What this means is I can rewrite this as 5U5 times 3U2, then minus 5U5 times U plus 5U5 times 2. Because notice how, close. So notice how 5 times 3 is 15, 5U5 and U become 5U6, and 5 times 2 is 10. So what's left is 5U5 because that's what's in common. And in big parentheses, we have 3U2 minus U plus 2. And that is your answer. Question 2 would like us to factor out the binomial. And since we have the same term, what we can do is we can just write the binomial, the parentheses part, which is p plus 5. And then for another group, we can write 8x plus 1, because technically there's a 1 right there in the front. Factor by grouping. So first, we're going to factor each part 2 at a time. In the first group, notice that both terms have the letter x in common. So you can write x and then parentheses y plus 8. In the next group, you can actually divide by 7. So we'll have 7, and what's left behind is y plus 8. Well, notice that the binomial that's in parentheses is the same. So we can factor by binomial. So it becomes y plus 8, and then x plus 7. Again, question 4 wants us to do grouping. In the first group, we can divide everything by 2a. And what's left behind is a2 minus 5b. In the next group, you can divide out 5b. And what's left behind is a2 minus 5b. Again, the binomial is the same. So what we can do is we can write a2 minus 5b, and then 2a plus 5b. Question 5, grouping. Again, we'll do the same thing. In the first group, we can divide out a. And if you factor out a, you're left with b minus 4. In the second group, you can factor out a negative 6. If you factor out negative 6, you're left with b minus 4. Well, the binomial is the same, so you can do b minus 4 and then a minus 6. And that is your answer. Factor each polynomial if possible. In question 6, this is the type of x squared plus bx plus c. So what that means is I look at the last number, which is 72, and I make a list of everything that multiplies to 72. So you got 1 times 72, 2 times 36, 3 times 24, 4 times 18, and 6 times 12, and 8 times 9. Then I look for a pair of numbers that add or subtract to make negative 18. In this case, I like 6 and 12 because negative 6 minus 12 is negative 18. So your answer becomes y minus 6 and y minus 12. Seven. I see the last number is 16. Numbers that make 16 can either be 16 and 1, or 8 and 2, or 4 and 4. Now, if I add everything up, I get 17, 10, and 8. The problem is the middle number is 6. There's no 6. So this is something that is called prime. All right, question 8. You'll notice that it begins with a negative. That's really a negative 1. And what we can do is factor out negative 1. And factoring out negative 1 changes the sign. So it becomes positive p2 plus 11p plus 30. Now we can do our factors of 30. So 30 can either be, I'm thinking 10 and 3 or 6 and 5. Those are some good factors. I like 6 and 5 because that adds up to 11. So you get p plus 6 and p plus 5. And you still got negative in front. All right, in number 9, you can factor out a 4. And if you do, you're left with a2 minus 2a minus 120. Let's look at factors of 120. There's 12 and 10. There's 15 and 8. There's 20 and 6. There's even 24 and 5. I like 12 and 10. I like it because negative 12 plus 10 equals to negative 2, which is what's in the middle. So this is going to become a minus 12 and a plus 10. And the 4 stays in front. Question 10. Factoring if possible. I could factor out 2b. And if you do, you're left with b2 minus 11b plus 24. If we look at numbers that multiply to 24, there's 12 and 2, there's 8 and 3, and there's 6 and 4. I like 8 and 3. Specifically, negative 8 minus 3 equals negative 11, which is the middle. So you're left with b minus 3 and b minus 8. The 2b will stay in the front. Question 11. So the last number is 36. Numbers that make 36 can either be 18 and 2, or 12 and 3, or 9 and 4, or 6 and 6. I like 9 and 4 because negative 9 plus 4 is negative 5. So we will have m minus 9n and m plus 4n. Question 12 is actually a factor by grouping. So we'll go 2 at a time. In the first group, we can factor out 9x. And what's left behind is x plus 6. The second group, we can factor out 10, which also leaves behind x plus 6. Now that the parentheses are the same, we may write x plus 6 and 9x plus 10. Okay, 13. We're not going to be able to divide everything by 12. So what we're going to have to do is, the first step, we're going to have to factor by grouping. And the first step to this is multiplying the first and last number. So 12 times 20 is 240. The next step is I have to think of factors of 240. Well, there's 24 and 10. There's 20 and 12. There's 30 and 8. There's 15 and, let's see, 15 and 16. I like 15 and 16 because that adds up to 31. So what you end up getting is 12H2 plus 15H plus 16H plus 20. We can factor by grouping. In the first group, 12H2 plus 15H, we could factor out 3H. And what's left behind is 4H plus 5. The second group, we can factor out 4. This also leaves behind 4H plus 5. Since the binomials are identical, we can rewrite as 4H plus 5, then 3H plus 4. And that is our answer. All right, same thing. If you multiply 2 times negative 14, you get negative 28. The next step is we have to make a list of numbers that multiply to 28. There's 28 and 1. There's 14 and 2. There's also 7 and 4. And because this is negative, we have to get numbers that subtract to make 3. I like 7 and 4 because 7 minus 4 equals 3. So you get 2x2 plus 7xy minus 4xy minus 14y2. We can now do grouping. In the first group, you can factor out x. And what's left behind is 2x plus 7y. The second group, you can factor out negative 2y. And what's left is 2x plus 7y. The binomials are the same. So you have 2x plus 7y, then x minus 2y. And that is the answer. Okay, 15. Before you start 15, notice that you can factor out R3 and T3. And if you do, what's left is 14R2 plus 13R plus 3. Now we can multiply first and last. 14 times 3 is 42. Numbers that make 42 can either be 42 and 1, 21 and 2, 14 and 3, or 7 and 6. I like 7 and 6 because that adds up to 13. So you end up having 14R2 plus 7R plus 6R plus 3. We're now ready to factor by grouping. In the first group, we could factor out 7R. This leaves behind 2R plus 1. The second group, we can factor out 3. This also leaves out 2R plus 1. The binomials are the same, so we can have 2R plus 1, and 7r plus 3. And then don't forget r3t3 comes down. And that is your answer. 16. We'll have to do factor by grouping. So first we'll have to multiply first and last. 7 times 8 is 56. Numbers that make 56 can either be 56 and 1, 28 and 2, 14 and 4, or 8 and 7. I like 14 and 4 because I can make that negative 18 if both 14 and 4 are negative. So, you get 7z2 minus 14z minus 4z plus 8. We're now ready to factor 2 at a time. So, first we can factor out 7z. This leaves behind z minus 2. Next we can factor out negative 4. This also leaves behind z minus 2. So the binomial is the same. So z minus 2 is the first, and then 7z minus 4 comes after. Okay, so 17 is an interesting problem. Notice that the first and last numbers are perfect squares. 25 is the same as 5z squared, and 4 is the same as 2 squared. And you know what? If you do 2 times 5z times 2, you do get 20z, which is in the middle, except it's negative. So what this means is you can rewrite this as 5z minus 2 and 5z minus 2. And that is your answer. In 18, we can factor everything by 3y. If you do, you get 4y2 plus 20y plus 25. But notice the 4y2 and the 25. They're perfect squares. That becomes 2y squared. This becomes 5 squared. And 2 times 2y times 5 is 20y, which is in the middle. So you can rewrite this as 2y plus 5 and 2y plus 5 again. And the 3y that we took out earlier just comes down. So that's your answer. 19. 19, you could attempt to do the square root stuff, but because you get 2x squared and 3 squared, but 2x times 2 times 3 is equal to 12x, which is not in the middle. So this is going to be a prime answer. All right. So that concludes part 1 of our review. Tune in to part 2 located on the semathlab.wikispaces.com to continue the review. Thank you.